Dr. Kanendra Naidu. Hello, sir. Yes, sir. Thank you, Kanendra Naidu, sir.
Yes, hello, good evening.
Good evening, sir. I think it is a late night for you.
Yeah, it is.
Anyhow, thank you so much for accepting our request and came forward to deliver your expertise.
Okay, thank you.
So let me introduce your biodata towards the participants. So Dr. Kanendra Naidu is a distinguished professor at University Technology Mara, UITM, with a master's and PhD in electrical engineering from University of Malaya. His expertise spans several critical areas in electrical engineering, including artificial intelligence, applications in power systems, intentional controlled islanding, networking reconfiguration, load frequency control optimization, energy management system, virtual power plant, sustainable energy integration, carbon emission analysis, and electric vehicles. Dr. Naidu has an extensive publication record with over 60 research articles published in high impact journal such as International Journal of Electrical Power and Energy Systems, IET Generation, Transmission and Distribution, IEEE Access, and the Journal of Energy Storage. His research has significantly impacted the field with over 2000 citations and H-index of 20, indicating the wide recognition and influence of his work. His role as reviewer for various prestigious journals underscores his expertise and standing in the academic community. His research has been supported by numerous grants where he has served as principal investigator and co-principal investigator. Notable projects including examining the role of virtual power plants VPP in providing frequency control auxiliary services, optimizing the placement of flexible AC transmission system, devices for voltage stability, and developing model for EV charging patterns, integrating photovoltaic based stations. Professionally, Dr. Naidu is an chartered engineering with IET UK, registered under the Board of Engineers, Malaysia BEM, and Malaysia Board of Technologists, MBOT, and a senior IEEE member. He is currently engaged with various industries as the technical consultant working on EV battery recycling technology, EVSC scheduling, and maximum demand reduction. With this brief introduction, I request participants, please utilize this opportunity because it is one of the good platform to explore or to interact with this type of eminent personalities. So I request Naidu sir, please go ahead with your sessions. Thank you.
Right, thank you, Dr. Ravi, for the very kind introduction. Right, and also a very good evening to all participants, and also thank you to IIT Kottayam for inviting me for this particular session. All right, so let me try to share my slides. I hope my slides are...
Yes, sir.
Yes, sir.
Visible.
Okay, all right, visible. Okay, right. So, very good evening. I think, and I know it is also around 8 p.m., right? I think it's around 8 p.m. over there, and it's quite late, so not to worry. So today, my topic will cover carbon capture, storage, and emission tracking. And what I'll be talking about is how to transform carbon management through technology and AI innovation, right? So again, my name is Kanendra, and I'm from UiTM in Malaysia. And I work with a lot of universities in India as well. Also have some of the students from India. And so today I won't call it a lecture session, but I just call it a sharing session. I just want to share what I know, what I work with the industry and also in academics, right? So I'll talk a little bit about the climate change, carbon management, the tracking of emission, the policies and future trends. And when we talk about carbon emission, or when we talk about all these renewable energy, sustainability, and all these terms are actually, how would I say, they're interrelated. So you would see the same term appearing over and over again. So you talk about recycling, and then we talk about reuse, we talk about refurbish, repurpose. End of the day, they are all tied to sustainability. So when we say sustainability, we will look at the main concept here, right? So I think all of us have heard the word sustainability. And what is sustainability? So if we look at the charter for the UCLA, so they actually said that the integration of environmental health, societal equity, social equity, and economic vitality. So these are the main three things. We talk about environment, society, and the economic. So when we talk about economic, we're talking about governance. So what does it mean? So this is the three words ESG. So you hear the word ESG a lot nowadays. So when we talk about sustainability, not only environment, we also have to look at how you provide sustainability in terms of people, manpower. And then what is the governance? What is the policy? What is the government role in ensuring sustainability? So there are a lot of sustainability projects, but if you really look at sustainability, the design part is only 20%. 80% comes from operation and maintenance. So even if you build a new building with all the latest technology, you put solar panel, you have energy efficient building and so on. During design, everything looks perfect, fine. But that is not the end goal, the objective. The objective is after that, how you maintain that building. So this is where a lot of failure happens. So when they build, everything is perfect. But after you run 1 year, 2 years, 3 years, that's when you have problem, they let go of all the sustainability goals. So you don't achieve proper sustainability. So that is the environment part, technical part. How about money? How are we going to make sure that it's financially sustainable, right? And also the people. So nowadays we can see that for us to run jobs and so on, you have integration of AI. So how can we make the jobs sustainable in this climate? So that is what sustainability is all about. It is interconnected between E, S, and G. So when we talk about AI, I think everyone is well aware what is artificial intelligence. And there's so many artificial intelligence tools nowadays. And people are using AI now even more. I believe everyone knows about ChatGPT. So GPTs are being used not only at student level, even at business level, at industry level. GPTs are used. Apart from that, you have a lot of AI-based tools for designing. You also have AI-based tools for calculation, writing reports, and whatnot, right? So these are all, we can term it emerging technologies, right? AI, even though has been there for 20 years, but now it is even more powerful. And when we talk about sustainability, how is it integrated in power system or in our daily life? So if you look at solar, right? And nowadays you can see solar energy or solar technology has saturated in the sense that everybody knows what solar is. The price is also a bit, it has dropped compared to when it first was introduced. And the technology is mature. So now they are going into further optimizing the solar. So if you go to the latest industrial convention, you can see what is going on. We are talking about how to optimize solar based on the weather pattern. We look at the weather, and on top of that, there's a lot of shading that happens on solar. They come up with new technology how to bypass the shading on the solar panel. And also you have new types of panel. Some of the panel are able to even operate when there is rain. They have a special type of piezo sensor to do that. So these are the various things that is going on in technology for renewable. And we also have wind turbine, biomass, biogas, and all these new, I won't say new, but how we can further optimize. Biomass is already there, but there is some issues with biomass and also biogas. Some of the plants being installed is not fully operational because of some operational issues. So how can we optimize this? So that's where AI comes in. And I think all of you would know about energy storage. And you have battery system, BESS or ESS, energy storage system. And nowadays, they are using all these new technologies, these battery technologies, to reduce electricity bill, especially in industries. Why is this happening? In the context of in the Malaysian power system, certain subsidy has been removed with respect to electricity. So companies might feel that will feel that their electricity price increase by 30%. So when it increase, how do you want to make sure that you can still maintain operation but reduce electricity bill? So you can use energy storage or grid storage. Grid batteries are there. And then you have predictive analysis. I think predictive analysis is quite, how would I say, it's quite prevalent now, especially for motors, induction motors in oil rigs. Okay, we want to look at how long the motor or the generator can be used, but also it can also be used for predicting your load profile, your forecast. So this has been done for many years. And then you have now, when we talk about climate, we talk about disaster management, and now we can see more and more natural disasters happening. So how can we identify when these natural disasters are going to happen? It can be flooding, can be hurricane or extreme weather conditions. So how can we inform earlier itself? And I think flooding has been occurring more frequently compared to 10 years ago, right? So how do you save people? What is the strategy to save people? So now they're using drone technology to map the areas where it's flooded, when people get stuck in the flooded area, right? So we have that to help us. And of course, environmental monitoring. We want to detect anomalies in the weather pattern. So we don't wait until the earthquake happens, or we don't wait until the hurricane happens and so on. We try to come up with an early prediction system so that we can warn the people that this is going to happen. At least people can be safe, right? And you can protect your assets. And also risk projection. So risk projection is also quite important because prediction of drought, heat wave, and what are the strategies to mitigate all these unwanted weather conditions that can affect our equipment. So nowadays there's a very important term. They call it resiliency. So resiliency is now, I would say for the past 2-3 years, has been the keyword or a very hot word, resiliency. So when you say your system is resilient, means it must be able to adapt to any varying or extreme conditions. whether it's a weather condition, or it could be a cyber physical attack and so on, right? So yeah, when we are building system now, not only sustainable, it has to be resilient. So these are the imaging techs and technologies. And if you look at solar panel nowadays, they are looking at material level, and they're improving the material even further. So they have a new type of panels, which is more cheaper, right? So it can reduce the cost price and also efficient. And if you look at solar panel, it is not really that efficient. We are talking about efficiency of a panel, average 18%, 20%, right? Maybe you can go up to 25%. And that is, of course, if you maintain the panel. So how can we increase the panel efficiency even further? Because as you know, the panel efficiency drops when there is, of course, dust or dirt, and also due to heat. And how about if your panel has hairline cracks? How do you detect all this? So you can make use of AI, okay, artificial intelligence. And another important thing is batteries. Everyone knows about EV nowadays. I think maybe 3-4 years ago, you might see one EV on the road 1 week, but now I think every day you'll see EVs on the road. You have so many new manufacturers. You have Tesla, you have BYD, so many different car companies that are manufacturing EV. But the main problem with the EV is the main element is the battery. The battery is based on lithium-ion battery. So lithium-ion battery is still not a solid state. It is still liquid. And what is the problem with this battery? Of course, it is better than the previous tech. But however, thermal runaway still happens. What is thermal runaway? Sometimes the battery is not stable. It can have a chemical reaction and it can burst into flames. And we are talking about especially when you meet in accident, or if the battery is exposed to certain conditions. And now the latest tech, of course, it is they are trying to integrate graphene over the lithium-ion battery. On top of graphene, they are going for solid state. So solid state battery will be a game changer. It is, I think, in lab conditions, prototype has been there, but it hasn't come up to commercial level yet. But I believe Toyota is already in that region, and some manufacturers are around that region of going for commercialization of those batteries. And of course, we are talking about fuel cell or hydrogen cell, which is also coming up. And we all have heard about blockchain and machine learning. So most of our system now are becoming deregulated. So when you say deregulated, means it's not centrally controlled. But when you deregulate a system, you're going to have another issue, which is there has to be some sort of management of the data integrity. So that's why blockchain has been used and can be used for newer technologies. And another important part, which I think we will talk a bit more further, is carbon capture and utilization, CCU. Sometimes it's called CCS, carbon capture and storage. And also have CCUS, carbon capture, utilization, storage and utilization, right? So when we talk about carbon capture, how are you going to capture this carbon and store it? So what is the most effective way of capturing this carbon? So machine learning can help you to predict this. And also, how can you optimize the carbon credit for your business operation? So what is the impact of the emerging tech? So when you have all this emerging technology, we are talking about our process is further optimized. And when it's optimized, we are talking about you're using AI, IoT, data analytics, and your operation is faster and better. I think one of the examples that happened in in Malaysia itself was one of the coffee companies, and they actually install CCTV, and this CCTV is integrated with AI and machine learning. So from that CCTV, they can actually, the AI can determine how long you're working. Meaning, what is the efficiency of your work? So it's, I mean, if they detect whether you're sitting down or whether you're standing or whether you're moving around or whether you're playing with the phone. So with that, they have identified that instead of 4 people to man the counter, you only need 3 people. So they reduce the workforce, right? So you optimize the process. Of course, in terms of labor, that is not a good example because you are reducing. But in terms of efficiency of the process, you enhance your operation in terms of cost and manpower, resource efficiency. Or maybe you can take that 1% and put it in a different department. Okay, maybe not efficient in that department. You can move the person to a different department. Smart factory, I think this is a very, how do I say, it's a common term, smart factory. Most of the factory is going for automation. Big factories are already automated. Smaller SME, smaller and medium industries are also going for automation, and also to increase productivity and energy efficiency. The other important term here is circular economy. So circular economy is now, is also a buzzword now. So why is it an important term? So basically, you want to make sure that you do not keep on buying new things, in the sense that, for example, EV battery. First life of an EV battery is almost 7 years, 7 to 8 years, first life. After 7 years or 8 years, after the first life is over, your battery's state of health will reduce. So when the state of health reduces, what does that mean? That means if last time you charge, it's like your handphone, right? When you first bought your handphone, when you charge your phone, you can maybe use the phone for 2 days. But nowadays, I think after 2 years, if you charge your phone, I think you need to charge 2 times in a day, right? So why is that happening? Because the state of health of the battery in the phone has reduced. And some of you might go to the shop and change the battery, or you change your phone. Fine. But how about an EV car? Maybe after 7 years, you might want to change your car, but the car is expensive, or you want to buy a new battery. Of course, the battery is also expensive. It is not a small battery. We are talking about a 400 kg or 500 kg battery. It is huge. A battery cost could come up to a new battery average maybe 50% of the car price. So are you still going to buy that? So it is better if we can recycle the battery and remanufacture the battery so that the cost of the new battery is lower, right? So that is circular economy. So we try to use back whatever waste that we produce and make it back into a remanufacture into a new item. And also microgrids. Microgrids are becoming very important. And now most of the microgrids are integrated. Maybe if you look at your area, you might already have a solar plant. You might have biomass, biogas energy. Everything is integrated in your neighborhood, in your town or province. So that itself is a hybrid renewable energy system. Okay. So yeah, so these are the impact of emerging technology. Another part I would like to say is climate change. So where is AI used? So nowadays you can use to detect how fast is the ice melting in the North Pole or the South Pole, right? So you can use satellite data, and with that, scientists will say, "Oh, okay, global warming is becoming even worse." And deforestation mapping. A lot of forests in different countries are being or facing deforestation due to who? Maybe due to some developers or some illegal contractors or whatsoever, they want to clear off the forest. So you can actually look at that image using a drone or satellite mapping, because it is very hard for people or officer to go and see the forest, deep into the forest. Nobody goes regularly, right? It is not easy to go. So using AI, it is easier for us to monitor this. And AI in climate risk prediction, especially in the African continent, right? So we look at the weather pattern, we are looking at heat pattern and so on, so that you can help a community which has no water. When we know the heat is going to increase, at least you can provide with natural resources. Of course, waste management, as I told you, the circular economy. Another important thing that they have done is ocean cleanup. So now you can use AI to detect your ocean, the amount of rubbish, the color of the water, if some oil spill, and so on. So you can do cleanup. You can clean the ocean easier now because you can already detect the issues. Okay, disaster prediction. When a disaster going to happen, AI can help us to predict that. And also reduce GHG, greenhouse gas emissions. And also, how can we reforest? Reforest, we can plant seeds so that you can have a forest going up, but it takes years, but at least you can use drone and do this. And also nowadays, if you look at the palm oil industry, so palm oil industry, it's, you have a huge plantation. Used to be manually, people used to go and check, but now you can just use drone to map the area. And from the drone, you can actually see which one is ripe to harvest, which one is still young. And also you can detect if there is any of the trees having, what would I call that? Having some sort of problem. Can be fungus or attacked by insects. So you can use drone mapping to actually look at that, and you can look at the color and you know, okay, this part is having problem, this plant is having issues, right? So yeah, so AI can help us in tackling our climate change, right? So let's go into carbon management. So carbon management is an important thing. Carbon management is quite advanced in European countries. And now in Southeast Asia, it is also becoming important, right? And how can we use AI and emerging tech for this adaptation climate, right? So let's look at emission, right? So we all know that what emission is. So you emit carbon, right? And when you emit carbon, what is GHG? So GHG is the greenhouse gas, and the gases that are emitted, for example, if you look at the bottom part, we have carbon dioxide, we have tropospheric ozone, we have methane, nitrous oxide, and other halogenated compounds. The main gases here is the carbon dioxide and also methane, right? So these are very dangerous to the environment. And these gases, once they are released, they will cause global warming because they have such properties that they will trap heat. But what are the causes of this greenhouse gas? Our activities, fossil fuel, even agriculture, energy production, right? So even we at home, we waste electricity, we travel daily, we are using fossil fuel to burn. So we are also contributing to the carbon emission, right? So what is the unit that they use to count this or to measure this? So we call it a CO2e, which is the carbon dioxide equivalent. So this is a standard unit for measuring emission. So why do we take this? So it simplifies the accounting process, means easier for us to calculate. So even though you are producing different gases, we try to calculate what is the equivalent of the CO2. So there's a formula, there's a constant, so you can convert that. And based on this, remember that we have 3 scopes of emission, right? Scope 1 is direct emission. Scope 2 is indirect emission. And scope 3 is something which is indirect, but it is, we are talking about your movement, we are talking about the process of producing that item and so on. So later on, I will cover in detail of what is scope 1, scope 2, and scope 3. And for example, if you are traveling from your house to the university, right? And you're either using a motorbike or you're using a car. And that car or the motorbike is fossil fuel. So there is a value for that, for the motorbike and also for the car, if you're using a software. What is the carbon you have emitted? You travel from your house to the university. But at the same time, if you use an EV bike or EV car to travel from your house to the university, of course, the reading for carbon emission is almost zero. Okay, your carbon emission is almost zero. Why I say almost? Because we also have to look at how the EV produced, that is scope 3. But if you talk about scope 1 traveling, it will be zero because you are not producing any carbon to the air, right? And of course, now we have carbon market. So we are talking about how we can reduce the carbon, but we want to incentivize people. Incentivize means we want to give some reward if you manage to reduce the carbon. So that's why there is a carbon market now, and we have something called carbon tax. So carbon tax is becoming more and more important. I'll talk about carbon tax later on. So why is this carbon emission dangerous? And I think all of you know about the United Nations, the goals. You have your, I believe, 17 goals, right? Your SDG. So one of it is climate action. So in the previous meeting, when they signed the Paris Agreement, they have, the countries, 195 countries have pledged to make sure that the temperature should be below 1.5 degrees Celsius. Okay, the increase in global temperature. So if you look at this graph here, you can actually see that during 1850s to 1900s, 1850 to 1900s, the average temperature was 1.32 degrees Celsius warmer than pre-industrial. Okay, prior to that is the pre-industrial age. But after that, during the 20th century, you can see the temperature increasing. The increase is 1.15. So what they are saying is, if the temperature increase greater than 1.15 degrees Celsius, the risk of extreme impact, severe weather event, harm to the ecosystem or to the community will happen even further. I mean, it escalates, it becomes even worse, right? And you do not need to even look at the graph. Just based on your experience, you can actually see that the weather event now is a little bit more unpredictable compared to maybe 10 or 20 years ago, right? And nowadays, I think flooding maybe occurs even more. And when you have heat, what do you call that? A drought or hot temperature, it is even hotter compared to last time, right? So these are all impacts of carbon emission, which causes the climate to change. So it is important we make sure that it is below 1.5 degree Celsius, the increase, okay, the average. But if you look at the report, and I've actually given all the references at the end of the slide, you can read the report. Up to 2017, when they look at the graph that they have drawn, you can actually see it is increasing. And if you do a projection, you can see that our warming rate is increased. And based on the analysis that have been done, it is found that the global surface temperature in September, October, and November has exceeded 1.5 degrees Celsius. Okay. So even prior to that, 2011 to 2020, it was already 1.1 degree Celsius. But we also have to remember that we cannot just take that value literally, because it can also be caused by events like extreme heat and so on, right? So you need a lot of data. You just cannot just take one average and then say, oh, okay, we are in extreme condition. No, the data that they take for 100 years and so on, right? Then you get a better picture of what is going on. So that's why you can see nowadays global agenda of governments are talking about climate change. But there is some person say, oh, okay, it is not really that hot. It is just a normal temperature increase. No, we are talking ahead in the future, because look at the trend here. You can actually see it is increasing, and also at this graph. Okay, it is slowly increasing. We don't want it to keep on increasing. We want it to go down. And if we look at the data, the highest emitter of carbon, the first is China, followed by United States, India, and European Union, right? So total of these four, countries and also continent, European Union is a continent, different countries. So it is almost 50% from these four regions, and then followed by other countries, Russia, Japan, Brazil, and so on. So you can actually see this data. So yeah. And when we talk about carbon emission, we also need to look at what is the relationship between the GDP, which is the country's economy, with the CO2 emission. So we have this graph here. So if you look at the graph, during pre-industrial times, as the income is a bit less, the environmental pollution is also less. But as the country becomes richer, the GDP, okay, the GDP increases, emission also increases. But beyond a threshold, as you have more and more technology, the emission reduces, declines. So what does that mean? This basically means that during our industrial economy, when we are building a lot of factories and so on, of course, our emission rise. Maybe let's take another 5 years. Maybe all of us, maybe majority of us change to EV car. So at least we can reduce the emission. And of course, the electricity is sourced by solar and so on, right? Compared to fossil fuel. Okay, so we can reduce emissions. And also, more and more renewable energy is in our system. So of course, there's an argument now. People are saying that why do you change to EV? Because you are taking the electricity from power plant, and the power plant is burning fossil fuel. Yes, that is one argument. But at the same time, the other argument is, let's say now, if all of us are driving a normal fossil fuel car, all of us are emitting carbon. Means the carbon is not controlled. It's all over the place. But if all the car change to EV, the carbon is only emitted by the power plant, at centralized area. And it's easier for us to control the emission at the plant with some technology, which I'll show it to you later. Instead of having carbon being emitted by all the cars, we centralize the emission. Easier for us to control the emission, right? And also nowadays, I believe all countries don't rely 100% on fossil fuel, coal plant. You also have large-scale solar. You also have hydroelectric. You also have wind for certain countries. Okay, you have wind. Right? And the other one is technology emission. So early adoption emission decline. So initially, when we go into all this technology and so on, the emission decline. But this is I would say, an inverse view, because as we adapt more and more, the emission rise. So this is like us right now. For example, when we used to have maybe one smartphone 15 years ago, but now if you look at you or us, each of us already have maybe 2 smartphones. We have a tablet, we have a laptop. One person already have 4 or 5 devices, maybe an AirPod and so on. And, imagine your whole, in one family, 5 people, more equipments, right? So that gives more energy demand. More energy demand means more power has to be produced. And if the country is fully or majority coal, means they have to build new coal plant or new fossil fuel based plant. So that means emission is going to rise. And you can look at the graph of any country. The demand of energy keep on increasing year by year. It will never reduce. Okay, because why? We are using more energy, right? So what is the strategy to reduce emission? Number one, we have to promote cleaner transport. So when we say cleaner transport, we are talking about bus, maybe EV bus or trains, instead of all using cars or motorbikes to motorcycles to travel, right? Of course, you have to enhance infrastructure, and also you have to be connected so that you can easily, from your house, go to your workplace or to the university easily without having you to drive or walk for a very long distance. Okay, it's easier. And you have to raise awareness. We have to talk about sustainability, not only for, this one I always used to say, not us engineers or technical person, but non-technical person also need to know about all this, right? Awareness. And of course, we have to boost technology innovation. We have to innovate newer technologies, and government have to support this, maybe by giving tax incentive and so on. And also open innovation. We have to collaborate further. And for example, now, one of the leading countries, let's say, for example, US having Tesla. And the next technology is, of course, going to be autonomous driving. So autonomous driving is the next part. Why that is very important? Because you can, if the car can drive by itself, that's going to be, I think, very productive. How is it productive? Because imagine this: if all the cars drive by itself, you can mitigate jam. You will not have traffic jams because they are able to communicate, and then they know, okay, if you travel at this speed at this time, then you are able to make sure that the traffic is flowing smoothly. So if you are able to reduce jam, then of course you're going to reduce carbon emission. But for that to happen, you need to look at how we can collaborate. So Tesla already have FSD, which is the driverless or autonomous driving. So how they can implement their FSD in different countries. But it's not as easy as just, okay, we just turn on and then it will drive by itself. No, you have to feed data into the car. What data? Map. And not any mapping, it has to be a very specific mapping. And we are talking about not something like Google Map or Waze. It has to be more accurate than that, drone mapping. And carbon capture. So this is, I believe, is going to be very important the next coming 5 years. So we want to capture the carbon. We don't want it to emit and go to the atmosphere. How are you going to store the carbon? Right? And if you are able to capture the carbon, this is the new technology. So you have to have some innovation. There's I will show some of the ways how they do it, but of course it's not perfect. More and more experiments need to be done. So if you can reduce carbon, we can mitigate climate change. And also we can use back the carbon we capture, repurpose back for some other thing, such as fuel. And of course, this is going to create new jobs in the future. So these are the terms. Because we look at all these terms that always comes out in industry and media. But just to share with you, so if you look at this, when you have the fossil carbon and it goes into the atmosphere. But for us to store it, we have to carbon capture and storage. We call it a CCS. Right? So how do we capture? A couple of ways. And when you capture this, you store it in underground, right? So this is able to reduce the emission. Okay, we can reduce, means we make it less, but we cannot remove the atmospheric CO2. We just reduce. So you can look at this diagram here. So from fossil carbon, we store it, and you can store it for hundreds of years underground. Right? The next one is carbon capture and utilization. So CCU. So CCU, if you look at this part of the diagram here, we reuse the carbon which is captured, we repurpose it as fuel or concrete, and then this carbon is used for other industries. Right? And the third one is carbon dioxide removal. So this one is for you to extract the CO2 from the air and then remove. So this is basically you're removing CO2 from the air. And this is one of the most efficient techniques, but these are all methods how we can reduce the carbon emission actively. These are not passive methods, these are active methods. But the technology is the question. Right? So the term here that they use is sequestration. So sequestration of the carbon. Basically, we are trying to eliminate carbon or minimize or remove the carbon. Right? So, and why are we doing this? We want to meet our net zero goal. So the goal, basically, the objective here is to remove carbon by, I think the net zero goal based on Paris Agreement is 2050, so that we can limit our global warming to 2 degrees Celsius, not to go higher. Earlier they say 1.5. 1.5 is already already a critical value. So we're talking about 2060, which is another 30 years, right? 35 years, right? So we don't want the temperature to rise. So if you look at this diagram here, you can see this carbon capture and separation. So it is injected. Okay, we capture the carbon and we inject into deep underground, right? So once you inject there, it will stay there. It will convert into a mineral and it will stay there. So that's why earlier I said, if we can control or centralize the carbon, it's easier for us to process. And of course, the trees, the forest, they can capture carbon, that is natural. And if you have peat swamp, okay. So there is a lot of this type of technology, but these are some of the countries in US, it's happening, North America, UAE, Australia, right? So it can stay underground for 10,000 years. So the main two methods, right, for CCS, for carbon storage, is either using biological or artificial method. So biological, obviously, we are talking about natural environment. Okay. Of course, biological is greater than the size, the scale is larger than geological. Why? Because we look at a forest, it's of course way much bigger than any man-made structure. So what are the techniques? Carbon sink. So carbon sink basically is you have some sort of lake, you have peat, swamp, you have forest. So forest, ocean, grassland, these are all natural carbon sink. So the carbon from the atmosphere will be captured by this greenery. And coastal wetland or the swamp area, it can absorb more carbon compared to forests. So even if you go to the mangrove swamp and all that, they're actually very good in absorbing carbon. And certain type of trees also can absorb carbon more efficiently. So you can actually see the new research trend here of if you're involved in maybe agriculture, what type of trees can we plant or have in your agriculture or your farm so that you can capture more carbon. Right? So oceans and forests absorb half of all the emissions. So they can capture more than they emit. Of course, they emit carbon, but they can absorb more. Okay, because if you talk about ocean, of course, you're going to say, oh, there's living things under the ocean and they are going to emit carbon and so on, right? But the capture rate is way greater than emission rate. Saline aquifers. So these are the carbon which is injected into the underground formation. Right? So actually one of the project is Citronelle project in Alabama, USA. And they have been, I believe from 2012 or 13, 2012, they've been operational and they have so far stored 150,000 tons of CO2. Okay. You can actually look at this project. They have shared their information. Right? And another technology, of course, is air filter, giant air filter. So basically, it's a very big filter. I know some of us have that small, portable filter in our house to purify, or they call it air purifier. Similar concept, but at a larger scale. And this is basically used to clean air. Okay, so you draw, and these are the filters. You can see the filters. So they filter out all these impurity. So one of the largest is the Xi'an air purifier in China, and it can process 353 million cubic feet of air daily. So it improves the air quality because the air quality in that province was very bad in China. And now with this air purifier, they have improved their air quality. So again, if you look at all this technology, it is there is a lot more room for improvement. Okay, we can improve this technology even further. So this is the one in Xi'an, and you look at it, it costs 2 million to build, and it is based in a city center. Okay, it is based in a city center. So you have to actually track where is the, let's say if you want to do it in your town or your province, where is the highest concentration of carbon? You have to do some sort of analysis. You cannot simply say the carbon is very high at the factory area. No, you have to analyze first. Okay, and then all this polluted air is sucked into the tower here, and they use solar panel actually to heat the air, which is a good thing because we can reduce grid energy. And once the air is hot, the air will start to rise up. And then there's a filter up there to clean the air. Similar to power plants, so they install the filters. So this filter can capture the carbon. So this Xi'an tower can clean almost 353 million cubic of air for a 4-mile radius. And they are planning to build another tower. Right, so yeah. Another one is aqueous amine-based CO2 capture. So basically what happens here, it is used in industrial process. So it is still, I wouldn't say experimental, some of it is still in experimental stage, minority of it being used. But what they are trying to do is they are trying to separate the carbon from your process in the factory or your industry. And it has to go through a gas chamber. And then they use a type of solvent to absorb. As you can see, you can capture the CO2 in one of the tanks there, right? So, but the issue here is the energy consumption is high. Okay? So this is also another technique. And there are many other techniques available. You have rock weathering, where you use silicate mineral to capture CO2. And also gas separation, you separate CO2 during the operation of your industrial operation. And bioenergy, okay, you can capture CO2 from your biomass energy production. You can use chemical looping method or cryogenic, which is using cooling technology to capture CO2 at higher rates. And nowadays, what is very famous is nanotechnology. Okay, right. So I think I saw the chat. There's a question on disposing EV batteries. I will share with you in a while. Right. So AI in emission tracking. So I think everyone knows about AI. AI is quite a common term nowadays, but I want to talk about how it can track emission, right? So AI is used in many sectors, right? But the reason why we use AI is for us to integrate it and make our process efficient, right? And if you talk about AI in logistics, big warehouses now use AI to manage their stocks, their logistic process, their freight management, the fleet management. They're using AI. And if you talk about transportation, AI again is used for autonomous driving, which I explained earlier. And your car has to be able to understand the geographical location of your area. And if you know, the technology is still developing, it is not finalized yet, and banking and so on and so on. But what I want to touch here is AI in transportation. Why AI in transportation? Because transport sector contributes the highest, one of the highest greenhouse gas emission. Okay, 1/3 of worldwide emission is caused by transportation sector. And why we say transportation sector? Because obviously all of us are driving. A lot of us are, even if you look at the train, bus, majority of bus still use fossil fuel. Not all are using EV. There are some EV buses. Your ship on the ocean, majority is fossil fuel. The big cargo ships. So all this contributes. Okay, not only cars. And if we can integrate AI, we can do autonomous vehicle. We can optimize public transport. We can do fleet management and route optimization. So this is what I talked about earlier. If you can optimize the route, you can go from point A to point B without facing jam, for example. Even I think now Waze or Google Map does that, but it is not really AI up to that level, because Waze or Google Map will tell you that there is a traffic jam. Okay, take another route. But that data is based on user. A lot of people, the more user uses that application, then from that it can tell you, oh, okay, there's a traffic jam here, use a different route. But we want that to improve even further if we have satellite or drone mapping, so that it can bring you and avoid, not only you, it can avoid many people from hitting into the jam. So you can manage fleet for lorries, for oil tanker, for ships, right? If you have a full autonomous system. And what is the impact? We can reduce emission even further. Right? And if you talk about industry, how AI helps in emission management, right? So AI can optimize emission reduction by, you can improve your efficiency, you can do monitoring, you can enable predictive detailing or predictive insight. So another important term in industry now is RUL, remaining useful life, RUL. Or for EV battery, we call it second life. second life of the battery. So when we talk about equipment, you want to prolong the machine lifespan. Let's say if you work in a factory, you have a motor. You don't want to wait until the motor is damaged. Only then you change the motor. Or even if you do scheduled maintenance, you wouldn't know when the motor is going to spoil. Predictive maintenance, scheduled maintenance cannot do that. Only thing that can help you is predictive maintenance. So if you use predictive maintenance based on AI, you can already estimate how long more the motor is going to operate before it fails. Normally in oil rig, they will tell you this motor can maybe operate for another 1,000 cycle. So how it will help the engineer is that the engineer is able to already buy a new motor, already buy the spare part. So when that happens, he can reduce the downtime. And you can, or you can repair the motor earlier, or you can change the motor. You see, so you can reduce downtime. Or not, if that incident happened, you have to wait another 1 day or 2 days or maybe a week for you to replace. So that is going to cause downtime to the operation. And IoT devices can help you to manage your consumption of electricity and so on. And as I told you, condition monitoring, if you do predictive maintenance, it can help your industry. Okay. So when we talk about climate tracking or for AI integration, there is one of these website software, Climate Trace. And you can actually go to this website and you can actually look at the live satellite imagery. So they take the satellite imagery or satellite images and they use AI to identify where emission is occurring. Okay. So here we can detect that there is a 2-mile methane plume, means methane gas being released somewhere in New Mexico. So this kind of AI tool with satellite imagery can help you, right? And I've also shared the website because some of these websites you have to have an account, you have to pay money, but some are free. And here I have actually taken this the data, and also it depends on how much IoT or how much sensor they have installed in those areas. So this is the data that I managed to capture, and you can zoom in to the country or to the province or to the town or to the city and see how much carbon is being released. And if you click, you can see the details, right? So I actually looked at the one in India. So they say, I think one of the highest is the Vindhyachal power station, followed by Mundra thermal power project. So amount of carbon being emitted by that power station. So you can see all these two are all power projects. The list is quite long. You can later you can look at it. So you can see the power plants are producing a lot of emission. So if you can control the emission here, we can reduce the carbon emission, right? So yeah, you can also go in detail, click one by one. And another tracker is called Carbon Mapper. This is also free. I think they might have some things that you need to pay, but most of it is free. And here you can actually click and you can see that there was a plume detected, right? And what is the source here? So you can see is CH4, which I believe is methane. I might be wrong, but it is CH4 being detected. And they also tell you the date it was detected. It's written there November 11, 2020. And the time it was detected. So you see, all this AI tool is actually helping us. So we as the engineer, or we are working for the utility or something. So when we see this, we can immediately go there to do some mitigation action before it becomes even worse. Don't let it become, higher level. When we see a little bit of this carbon being emitted, we rush there. It could be a forest fire, it could be a factory in fire, or some unwanted thing that has happened. So you can use these to detect, right? Of course, if you do some coding, you can automatically alert a sensor in your office or whatsoever to tell that something is happening here, some action has to be taken. So this is monitoring, okay? It's not up to the level of action, corrective action. So for AI integration, it all depends on your sensors, okay? And also based on the sensors that you use and how good your sensors are, and that helps you to do prediction even with higher accuracy, okay? So it all depends on how good your system can see. So how does the system see? Using your IoTs, your whichever industrial sensors that you have, right? So there are 3 layers. You have to monitor data. How do you monitor data? Whatever sensors that you use, and what is the purpose of using the sensor. If you want to detect heat, you have to obviously use a heat sensor. If you want to detect images, of course, a camera. If you want to detect current or voltage, you have to use a ammeter or voltmeter, and so on. So first of all, you have to identify what type of sensors are you going to use to monitor the system. And then, of course, you have the cloud computing. This layer, because nowadays everything is being pushed to the cloud, you have the node and the edges. You talk about big data, you talk about big data processing, machine learning. So you can do all the processing in the cloud, right? You do whatever processing that you need. And after you have processed all the data, you have to push back the data back down to the user, which is to visualize data. Because you visualize data, you want to look at statistics, you want to look at the bar chart, you want to look at the percentage. That is the display layer. So you have these 3 layers when it comes to AI integration for you to do emission tracking. It doesn't only apply for emission tracking. It applies for any part of AI integration, because you need to have all these 3 layers, right? So I'll go a little bit into the policies, regulatory frameworks. So governments are becoming more strict in enforcing emission regulation. In US, you have the EPA, and one of the standard is the main one that we all use is ISO 14064. For you to, it outlines what you need to do to reduce emission. And you have to be aware, because nowadays it's not a small matter. So I think all of you would have heard the scandal with which was accused of in Volkswagen, and also in Japan, and also in Toyota, which they have accused, they have misreported the emission level. Okay, they use a different setting when they did the testing for their car or automobile. You can read about this online. I think it was quite famous in a couple of months back. And also, they are looking at carbon tax, meaning if you have a factory, let's say you are producing something which is sold to Europe. Later, now maybe you just produce, let's say it's a food item. You produce the food and you sell. They just buy. But in the future, they're going to ask, what is your carbon emission? If your factory does not have solar, let's say, for example, don't have solar, it is purely just taking power from the grid, they will impose a tax on you. Means your price becomes higher when you sell. So that is carbon tax, one way of how they do carbon tax. And Singapore has introduced carbon tax actually in 2019. So they will look at the carbon emission of your factory, of your industry, of your company. And then based on that, they will charge you a certain amount of penalty. So you want to reduce the carbon tax. So also you have to give incentive for companies who want to do this carbon emission reduction. So Malaysia and Japan gives you allowance in the income tax if you want to buy items or equipment such as solar panel and so on for you to reduce your carbon emission. And you can see the price, the carbon tax price. I'm taking Singapore. So first was at how much is it? $5, okay, for tera CO carbon dioxide emission. And starting from 2024, they increased the price to $25. And then soon at 2026, it's going to be $45. It's going to keep on increasing. So what does that actually mean? Means the product that you sell or the services that you give, if it emits a lot of carbon, your factory emits a lot of carbon, you'll be taxed. And what happens if you are taxed? You sell the product at higher price. So who will be affected? The consumer. But you also have to remember, if you sell at higher price, people will go, people want to buy something cheaper. So if your product is very expensive because of the carbon tax, people won't buy your product. They will go for another product which is cheaper, which has less carbon tax, for example, right? So it will affect, especially if you export outside the country, right? Your product has to be taxed. If it's taxed, then you sell at a higher price. And if you sell at a higher price, consumer is not going to be happy. We are not, of course, you are not going to be happy buying something at a very expensive price. Maybe last time was $10 and now it's $20. Then of course you're not going to be happy, right? So it is very important to manage carbon footprint, not only at industry, but also at residential level. Even in our homes, we have to have energy efficiency. If possible, I mean, it's expensive, I know, but if you have the economic budget, please install solar panel for your house if it's possible. And of course, we try to use more public transport. And maybe if I said, oh, all of us change to EV, it is not a very good suggestion, because of course the price of EV is expensive. But maybe we can change to hybrid and then maybe EV in the future. And reduce, reuse, recycle. I think this is all something that we all know of. And also nowadays they have green building index to see how green your building is. So if you build a new building, I was involved in building one of such buildings where the air conditioner, you only open at night when the price of electricity is cheap. In the morning and after, you do not need to open. There is a way how you can manage to reduce the temperature without using air conditioner. We call it some sort of cooling system. And also lights. If you design your building properly, you do not need to turn on lights in the morning and afternoon. You can use natural sunlight. But to design that, there is a way how you design that. Right? There are many ways, but you have to implement that design. Right? So that is green building. Okay, and of course, just now I told you that you have to calculate carbon capture. How do you calculate carbon capture? There are a lot of softwares. Okay, one of the software I have used is LCOS by Universe. They are actually giving it, how you say, trial license. Also, there is a lot of free softwares as well. One of it is from the Bar Council UK. I've used that as well. You can calculate what is the carbon emission. Right? I also, with my student, have developed a carbon calculator for our university, and we managed to calculate, and we found out that scope 3 is the highest. So what is, just quickly I want to say, scope 1 is, if let's say you're doing something in your company, you're burning something, the smoke is coming out, whether it's methane or whatever gas, that is scope direct emission. Scope 2 is, if you use electricity, you don't have solar, you use from grid, and it's coal power plant, so that is scope 2. Scope 3 is indirect emission. For example, you travel from your house, from the house to your office using car, and your car is, as I told you, is fossil fuel, petrol car. So that is scope 3, right? So of course, there's more things about scope 3. I'm just giving you a simple example. So with this, once we know this value, then you can reduce what need to turn off, which can be reduced. So we can see here scope 1 and 2 for the university is very low. The highest is scope 3. A lot of traveling and some other things. So you can see the most highest number is car, and also the lift being used very frequently. So maybe we need to find a way. Maybe we tell, maybe for the first 5 floors or maybe first 4 floors, the lift won't work. Maybe the lift will only work after the 4th floor. So people have to use the stairs. So we reduce electricity. Okay, just an example. Right? So finally is the future trend. Okay, I don't want to call this future trend because not really future, because we're already doing this. Carbon storage, utilization and storage. This is going to become more and more important in the next coming years. Circular economy. This is basically on EV batteries. So earlier, one of the participant asked, what should we do to dispose the EV batteries? So you have to be very careful when you dispose these EV batteries. These EV batteries, you cannot just throw them away because they are still, they are chemical product, right? So there is a process. You can, if you want to recycle the battery, you have to first discharge the battery. After you have discharged the battery, you have to actually bring it to a recycling facility. So how do you recycle? You can either use, they call it pyrology or hydrology. Pyrology means you burn at very high temperature. Hydrology, you dissolve the battery using chemical. But these two processes, of course, it is very energy intensive. And after you have dissolved the battery, you have to send to a facility, because what will happen is the battery will produce something called, we call it the black mass or black sand, for example. So from that particular sand, you have to extract back the nickel, cadmium, lithium, and so on. So when you extract back all the minerals, you can use that to remanufacture a new battery, right? So it is circular economy, means from a new battery, you use 7 years, recycle, and then you build back a new battery. So that is called the circular economy for EV battery, right? And then AI and automation, you can use AI to automate your process or operation in your plants, in your factories. Electrification of transport, we're not only talking about EV cars, we're talking about EV buses, EV trains, EV ships, and so on. And renewable energy, we need to see more and more renewable energy penetration. Now the latest one is floating solar. Thailand is doing quite well in this, Indonesia as well. For Malaysia, we are just starting in Sabah for floating solar panel. I believe some other countries have that, but they are going in a bigger scale, right? To use solar panel on the dam, okay, the water dam, they put solar panel or lake. So the final word here is that sustainability is not the job of engineers alone, okay? It requires effort of all individual, organization, and government to create a sustainable future for all. Right? It's not like, oh, I'm electrical engineer or I'm chemical engineer, it's my job. No, it's everybody's job, right? And also it is not, you cannot say, oh, only industry, big factory have to take care of sustainability. No. We at home, we also have to practice sustainability. It's all of our effort, right? And so being said, so thank you. And if there's any questions, please do ask. Right, thanks.
Yeah, thank you so much, sir.
Okay, thank you.
Your session was very informative. Let us, we will ask the feedback from the participants. They're having some few questions are there in chat box.
Okay.
The question is, sir, what should we do dispose the EV batteries?
Okay, all right. Yeah. So as explained earlier, so for us to dispose EV battery, we have to first see. There's a new term here. They call it a battery passport. Okay, we call it digital battery passport. So each battery, when the car is in your country, or when you buy the car, each battery will have a unique code. We call it a passport. So that will say, for example, if when you buy the car, that battery belongs to under your care. I mean, you own the car and the battery. Okay, last time you only have registration number, chassis number for the car, but now car and battery. So after 7 years, what will happen to the battery? So the battery you have to bring back to the manufacturer and check. Is the battery still okay or not okay? If the battery is not okay, they either will repair the battery or repurpose the battery, means they use the battery for some other purpose like energy storage. Repair means they will open up the battery, they repair some parts, and then maybe use it for forklift or some other application. Or the worst case, if the car is met with an accident or the battery is damaged, then they have to recycle the battery. You have to bring to recycling facility and then break down the battery, recycle, and once recycle, you have to remanufacture. Because I think starting 2030, if I'm not mistaken, European Union have said that because now the battery after your car is more than 7 years or whatsoever, the battery goes back to the country where it's manufactured. If you buy the car from US, maybe it goes back to US. But after 2030, they don't want that to happen. It should happen inside the country. So the battery, whatever, you remanufacture inside the country, not export the waste out. All right.
Yeah, and another question, sir, is there a concept of manufacturing responsibility with respect to their manufactured products? In chat box, they are sending.
Yeah, okay. All right, thank you. So manufacturer's responsibility. Okay, let's take an example. If we talk about EV, okay, that's one of the interesting example. So now when we talk about EV especially, because it's a highly chemical product, the battery. So that's why now governments are introducing the battery passport. So once the battery passport is there, there's the responsibility is the most important part. So who holds the responsibility? Should be the manufacturer. And after 7 years, if you sell the car to somebody, who holds the responsibility now? Is it still the original manufacturer or the second-hand car dealer? So this one is what they are trying to put it in the framework, so that there has to be some sort of responsibility. Okay, and I saw another question. I hope I'm able to answer the question. The carbon calculator, is it designed on real-time data? Which software was used to measure the CO2 in the 3 scope? Right, so the carbon calculator, yes. Usually when you do this carbon audit, as of now, like for example, energy audit, I'm not sure about the situation in India. In Malaysia, for energy audit, you need to have a certification. You must be a degree in engineering, electrical engineer, and you must get you have to sit to get competency as an energy auditor before you do the energy audit. For carbon audit, so far there is no strong regulation as in the competency and so on. But of course, there are a lot of companies which I showed are doing the carbon calculator. So the carbon calculator, you have to go and gather the data, real-time data. But you usually will do it once a year. So you take all the important data, and when they calculate the carbon calculator for your carbon emission for the factory, actually they go building by building. They won't go very detailed like one room and so on. No, they go building by building. So yeah, because if you go room by room, yeah, I know the data will change, but they tend to take an average value for that. Yeah. And
Yes,
well,
sir. Another
okay.
question.
Yeah.
What is your opinion? Will the hydrogen fuel cell technology take over the EV technology?
Okay. All right. Interesting question. So I think recently, I think the manufacturer, I think Toyota is going for the hydrogen fuel cell. And in Malaysia, in the eastern Malaysia, they're actually going for hydrogen fuel cell. I think we have like 2 or 3 hydrogen pump for hydrogen car, and they're also embarking on hydrogen, what do you call train transit, light rail transit based on hydrogen. But again, yes, it is a good source, but the problem is, I believe the technology level has not reached up to that point yet. Number one is storing of the hydrogen. It is gas. It's very highly combustible. And number two is the efficiency, because one of the issues they were saying that when you store the hydrogen, and when it converts and it loses its efficiency. So if we can address the efficiency issue, and also we can address the storage issue of the hydrogen, then it will be, I think it will be good. But I don't see it in the coming years, because EV is there. Maybe after 10 years, when the technology is mature for hydrogen, then maybe we would see more and more hydrogen. But then again, that's just based on my personal opinion.
Yes, sir. Another question.
Mhm.
Sir, it is said that the solar panels pose a threat after a few years. When we dispose them, what is your
Uh-huh.
opinion on this?
Correct, correct. That's actually very true. Even
Yes.
during manufacturing of solar panel, a lot of risk is involved, because there is some sort of chemical involved in the panels. And when you dispose the panel, it's going to also cause a very big issue. But as I can see so far, because the panel lasts for 25 years, and a lot of panels are still up there, it hasn't become a big problem yet. But yes, it is going to become a huge issue when they replace the panels. And if you start, disposing more and more panels, it will become a huge issue. And of course, there is also a product or machine to recycle the panels, but it is pricey, because technology for recycling is there. Recycling, for example, recycling plastic, recycling even solar panel, the technology has been there, and even EV battery technology is there. But the price. And number two, if you invest in that business, you must get back your return of investment. But in order for you to get the return of investment, you must have steady waste or steady rubbish. Means you have to consistently have that panel coming in every month. You have 10,000 kilograms of solar panel coming in. If you are not able to do that, then your business runs into problem. And this thing has happened in the company called Northvolt in Europe. I forgot, is it Denmark or which one was it? So they built the EV recycling plant, but you need waste for you to generate your income. If you don't get waste consistently, then you're going to have issues in terms of commercial. Apart from technology, is commercial. Yeah.
Yes, sir. That's all the questions from the participants. If anybody having question, you can turn on your mic and you can ask. You can interact with resource person.
Hello,
Okay.
sir.
Participants.
This is Seema from Bennett University, Greater Noida.
All right.
So I'm not asking any question. I'm just like trying to say something to you. Like
Yeah.
we humans are polluting everything. We are destroying our water resources, air quality. We are destroying even our rivers. I mean, I'm staying in Greater Noida, so Yamuna River is nearby to us. So last week I visited to that area, and I have seen it's not a river. It's like a, what you can say, gutter. Basically, you can say that much we are polluted. And what we are doing, we are destroying everything, and then we are finding solution for that. Are you
Correct.
getting my point? So, but
Yeah.
how much we can save? Because some people are like conscious for sustainable living nowadays. I do live a sustainable life from last 7 years. I manage all my waste. You are saying hours. I am following 7 hours at my home. But when I see other people, they are just littering. They are not conscious for the resources, wasting food. In my college itself, students waste lot of food because obviously it affects 1% GDP of a country. Food waste. Okay. So how much like technology can solve these issues, because awareness is not there. So don't you think technology should be developed to create an awareness amongst the humans? See, because of the impact is not only on human, like we are destroying resources, landfill is there, but it is affecting our other species like birds, animals. They are going to extinct. No, so can't you think like how we can resolve this issue? Because awareness, I think it's a biggest thing.
Correct.
So can you just focus on this, like
Yeah,
can improve the situations?
totally agree. Because thank you for your statement. I think it's very true. So technology is only a tool. It can help us to monitor. Yeah, but the most important is the awareness, and this is why I think at university level we have all this OB now. I think this outcome, and they have put sustainability in every part. Yeah, it is true. At our level, we are trying to go to schools, high schools, to students to give more and more on awareness. But end of the day, we need our own effort and initiative as well.
I mean to say actions are more important. Sustainability is on paper only, but in implementing things, people are
Correct.
not aware what they can do, what's their contribution. Everybody's contribution is equally important because everybody is consuming resources, everybody is polluting our planet. So
Correct.
I don't know
Agree.
how to resolve this issue.
I think it's a very big issue. They are trying to come up with some objective and goal, but as what I mentioned, on paper, even when you design a building, on paper everything is nice, but most important is how you maintain and how you operate. And if people don't take this awareness strict properly, then you waste all the effort for sustainability.
Because so there are 3 P's, no? Profit, planet, and people. So mostly people are thinking of profit only, not for the planet. So I don't think it will be a sustainable option unless and until we all are like conscious for this planet. And it's the only home we have. No, I don't know. People are like in 70, 80 years, they are destroying a lot the resources. No, and it's like going in and the damage is not repairable now. In that situation, we all are there. You talked about ocean cleanups and all that. Why we are littering waste in our water bodies? I don't understand. And why then we are developing a technology to clean our oceans? Like, what is the sense of doing such thing? No.
Correct. Yeah. So I totally agree. I hope there's more consciousness, especially on sustainability and taking care of our planet, so that we don't need to do, extra things just to solve these, issues to take care. If we all have that, I think we won't have much of these issues. Agree?
May I ask you one question?
Yes. Yes.
I may not be right. I may not be right to ask you, but let me try to understand. The carbon collection condensation has been initiated in India, either from your end or from any other participant.
Okay. Carbon collection is. Oh, okay. Okay. Carbon collection and condensation is in.
Below the ground level.
Yeah, because I am not very sure about the situation.
Any other participant, if they have any idea about this.
In India, because now only slowly they are starting. The one that has lead in Southeast Asia so far is Singapore. They have done that. And even in Malaysia also, it is only starting next year and so on. So it is still at a very infancy stage. I think as of now, it's only awareness stage and so on, because especially Southeast Asian countries, I mean, countries here, we are exporting a lot of our goods to European countries. And once this is implemented, then we can see this carbon tax happening, and they will have the carbon credit. So once they have an institute or organization that gives out carbon credit, then I think it will be going on full force. So as of now, it's only at the infancy stage. I don't believe it is fully implemented up to that level yet.
That is a good concept what you have shared with us, because it's a quite innovative idea. That is, as you mentioned, it is going to fill the under the ground and is going to convert it to the mineral.
Right.
That's excellent idea. So somebody can take initiative from the research institutions. It may go up to the ministry level. They
Right.
can come out with some innovative idea. Thank you very much for that.
No
I'm
worries.
Ravindra from Myanmar. Okay, thank you.
Okay, Dr. Ravindra. Right.
Yeah, very nice. Any more queries from the participants?
There is a question. The production of EV batteries mining is increased by 200% last year. How it will equal the emission of CO2? Production is produces CO2. Yes. Okay. A good question, because production of EV batteries itself is CO2 intensive. Means it emits carbon. They, based on research, they say usually it will take 5 to 7 years to equate for the EV car to be clean. Meaning, when you buy EV car, you cannot straight away say that my EV car is zero emission. No, because the car itself use battery mining. They mine the mineral for the battery. So it will take 7 years for the car to be clean. But now, if we can remanufacture the battery, means from statistics, 95% of the chemical, because it's a chemical process, can be recovered back from the battery. Means the new EV batteries which has been remanufactured, then that we can call it as clean battery, because it's already been mined before and we already equate the CO2 emission after the 7 years. Then if we use that battery, we recycle it, then it will be a clean battery. So in places where coal fuel power plant source can we find it? Okay, I hope that answers the question. In places where coal fuel power plants are the source for generation, can we find any use of EV? So if you have, I believe most countries, Asian countries, maybe majority is fuel power plant. Just to give context, in Malaysia, 80% is still coal fuel or fossil fuel. Only 20% is RE. The use of EV, yes, that's the argument. So my argument would be, instead of us emitting the carbon separately in all the cars, it will be better if we can centralize the emission. So if we can centralize the emission, then EV will be useful in that sense. Yes, someone has shared that waste disposal is a collective effort from both public, government, and civil. Yes, so waste disposal is a collective effort, and the Department of Environment here has going to also introduce, I think it's called a waste tax or something, waste penalty. So the more waste you produce, the more penalty you have to pay. So they are doing the paperwork for that. So it is better if you reduce, recycle.
Yes, exactly.
Yeah.
Sir, another thing, some research scholar, I think he's a research scholar or somebody. Can we get any free Indian or land mining related data set available?
Okay, mining data set. I have seen some of the mining data set, but I didn't check for which country or which location. But there are some freely available data set, but most of the data set are purchasable. We need to buy the data set, but I can check and see if it's available.
Fine, sir. That's all, sir.
Okay, all right.
Fine.
Okay.
Any more queries from the participants?
No, sir. Thank you so much.
Thank you. Thank you all. Naidu sir, thank you so much. It is informative, because in chat box they are sending that nice session like that.
Okay. Thank you.
That they are very happy.
Thank you.
I need to conclude this session. Actually, you started from the sustainability, AI emerging technology, introduction to emerging technologies, carbon emission, like GDP versus CO2 emission, and renewable energy impact, carbon capture and storage importance, carbon capture technology, then like AI integrating emission and how helps in emission management and climatic trace, and AI to industry, and also regulatory framework. I think mostly I go through that these topics. It is a very informative, sir. Uh, I think thank you so much. I don't know how could say thanks to you because of
Thank you.
even though you are in hectic schedule, you accept my request. Once
No
again,
problem.
thank you so much because now your time is approximately 12:15. I think 12 crossed. You came to an AM. So it's a long time for you, but anyhow, it's a very good informative, sir.
Okay.
Thank you so much from my
Thank you.
bottom of heart.
Thank
And
you,
also
Dr. Ravi.
thank you
Thank
so
you
much
for-
from our institute also. We will collaborate with you. We will work together.
Thank you.
And once again, thank you so much.
Thank you. Thank you. Thank you to
Thank you,
everyone.
sir.
Thank you.
I request participants, please fill the Google form. It is also one of the consideration parameter for the attendance. But we are taking attendance from the both from the Zoom platform as well as from the Google form. So I request you, please be stay the session whenever will be started and ending, because it is a most important initiative given by the AICTE ATAL. So we have to utilize it perfectly. Then the attendance also will be calculated, as I said, based on both cases from the Zoom as well as from the feedback also. One more thing, from the tomorrow onwards, sessions will be started at 6 p.m. and ends at 9 p.m. I request you all, please be join the 5 minutes, 10 minutes before, so that we will start the session sharp at 6 o'clock. The tomorrow session already shared you through mail regarding the schedule. The tomorrow will be session will be taking care of the IIT Roorkee Professor Samit Mitra. So that I request you all, please be in on time to the sessions for the participation. So once again, thank you so much. Have a great day.
Sir, may I know the feedback form, sir? Link?
Yeah, just now I shared you in chat box.
Okay. Okay.
I shared you in chat box, sir. Once again, I am sharing.
Okay, sir.
Right. So any more hurdles you are facing, please let me know, or any problems, because your feedback is most important for us.
Sir. Link is
The
not
form is
available.
not available, sir.
Is not
Yeah,
available.
link
Link
I
is not
shared
there.
you already. Now also I shared in chat
Sir,
box.
link is not available, sir.
Link is not available, sir.
Only text message is available, sir.
Yeah, once again I will share you through the mail also. You can check later.
Mail.
Right. I will forward to you all the participants link, Google link I will share you. You can check that. You can fill that. No problem. Before tomorrow evening 4 o'clock, you have to
So
submit
kindly
that.
share the link on this chat box, sir. Actually, we are
Yeah,
waiting.
I shared you already, sir.
So it is not available. So it is not available. I think
It's
so.
not shared, sir.
You have not find anywhere, sir.
So I think you shared, you are not select the option.
Sir, it is
in
not
meeting
there.
No,
group.
no,
Can you share in
already.
WhatsApp group, sir?
Okay, okay. I will
Maybe
share you in
share
WhatsApp
personally
group
to
also.
someone.
Sir, I think
Not
you
available,
shouldn't.
sir.
Yeah, yeah.
It's enough to share in chat box link. No need of sharing in WhatsApp group. Please take it from the chat box, sir. Please share it once more. No need of sharing in WhatsApp group, sir. Thank you.
Okay. Please be follow on time, and also some of the participants, I think few participants, approximately 3 to 4 persons, they entered in the portal wrong mail ID. So if possible, you send to the request to the AICTE portal, AICTE mail. Already you got the registration. If not, you go to that website, you correct your mail ID, then only you will get the information from our side.
Can we wind up the session then?
Yeah.
Hello.
Everybody
Hello.
has
There
got
is-
link. Yeah.
Sir,
yeah.
feedback
No,
link,
not
feedback link is
available.
not available.
There is
Link is
not
not
link
available, ma'am.
Link is not.
Link is
link
not
is
came.
not available in
Link
the
is
chat
not
box.
there.
Link is not
Kindly
available.
check
What
the
is
chat
this?
box.
Sir, we didn't
Ma'am,
get
we are
any.
checking the chat box only.
A
Links
link
not
on
came.
the chat box. Sorry.
I'm
Sir,
sharing
I
the
said
Important, sir.
link
you are
always. Please, you can
admin
check.
only or host only chat, sir.
Once
It
you
is not
check,
available
sir.
in the
But not
party.
even one
Link is not
participant is
available.
able
Not
to
even
find
one
the
link
link,
we
sir.
saw.
Actually, is there
Okay.
any link or
Sir,
not,
check
ma'am?
one
Is there any link available to send?
Not available. Ma'am, not
We are
available, ma'am.
checking
Not available in the chat
from
box.
first to last
Consider I
message.
didn't get the link, ma'am.
Ma'am,
Link not available, ma'am.
Okay. Let me check. No worry. No worry.
Please check once again and share the link, sir.
Sure. I will share you through mail. Okay. Don't worry. For today mail, today only I will share you the mail. I will check the technical support also. Okay. From tomorrow onwards, you won't get any mail or any communication through WhatsApp. Okay.
Okay, sir. Okay, thank you. Please close. Okay, sir. Thank you, and please close the session.
Thank you so much.
Sir, I have not attached in the WhatsApp group, sir. Can you please
What
share the
about today,
WhatsApp
sir?
group link so that I can attach over there? I am not in the WhatsApp group, sir.
So I shared you link, sir. You can join in that WhatsApp group. Already shared the link.
Sir, where you can share, sir, link? Where you have to share the...
Sir, I shared the WhatsApp link at the time of confirmation. Confirmation mail you got the first mail itself from my side.
WhatsApp
In
link,
that
okay,
WhatsApp
sir.
link also there.
In feedback link, sir, today's session?
Yeah, that's what I'm telling you, sir. I am sharing in the WhatsApp. You are not visible. Once again, I will share you through mail. You can fill through mail, right? Okay.
Okay, sir.
Okay.
Fine.
Okay, sir.
Thank you so
Good
much.
night.
Good night. Have a great day.
Good night,
Thank
sir.
you.